Hi everyone, thank you all for joining to this presentation. Today we are going to talk about the system for analysis of big data from social media. Professor Dmitry Lande, Associate Professor Igor Subach and Professor Alexander Puchkov are the author of this work. We want to start from the fact that currently in the hybrid war with the development information component at many levels of government, there is a need to take into account information that appears in social media. A significant amount of information source in global networks contain various expert assessments, some of which are associated with the implementation of information threat, in particular cyber threat. The goal of this work is the description of the technological foundation and tools for analyzing the content of social networks on cybersecurity. The corporate system with the maximum use of open access component to automate the process of searching, monitoring, collecting, processing, analyzing, accumulating and storing information and then providing it to users and interaction decision support subsystems. One of the most important tools for ensuring cybersecurity today is open source intelligence, or cite, in other words. One of the areas of intelligence, which includes the search, selection, and collection of intelligent information obtained from public source, and analyzing of this information. The essence of the OSINT process is to search and analyze information obtained from the open source, selecting information and in further analysis, generating reports on the object of observation. OSINT in cybersecurity is determined by the number of aspects, including promptness of the receipt, volume, quality, reliability, ease of further use, cost of receipt, etc. When creating system for analyzing information from social media, it is necessary to solve the problem of large amounts of data obtained for analysis and tendency to constant change. These problems and ways to overcome it are called big data today. Big data is a term that means a lot of data sets, so voluminous and complex that makes it possible to process them using the exciting traditional database and application management tools. When collecting and analyzing open data from the internet, problems in processing large amount of data of multilingual dynamic information source and search the necessary information and navigation in dynamic information flows arise. A huge number of multilingual dynamic information resource, the dominance of information noise makes it difficult to find the necessary information, operational analysis, and hence the use of open source in information and analytical work. Most of above problems are topical issues of semantic processing of large dynamic information text arrays. Currently, technological concepts such as big data, complex network, cloud computing, text and data mining are used to solve these problems. Over the past few years, various systems for storing and processing large amounts of data have appeared. In presented system, Elastic Stack was used. Elastic Stack is an ecosystem of components that are used to search and process data. The main components of Elastic Stack are Kibana, as well as Logstash, Bits, XPack, and Elasticsearch. Sphinx is a full-text search engine for big data. It is used as a search engine in the currently built exciting system, which is described in this presentation. Neo4j is a graph open-source Java database management system with transaction support for the processing of conceptual networks of semantic search within the framework of analyzing big data from social media. A relevant approach to solving the problem of creating such a corporate system under consideration is a simultaneous use of methods and tools of information retrieval, data analysis, and aggregation of information flows. Create a system for analysis of big data from social media provides automatic processing of full text from social media for a certain period of time. Information is collected in the search mode on social media, websites, social networks, instant messages, blogs, etc. The queries are read by the program from special configuration tables. Next step is the search and output records matching queries. After that, unique records are written to the server database. The system that is described includes personalization tools providing online access to database, including from mobile device, from which the possibilities of RSS formats are widely used. This presentation justifies choice of ready-made software components. Also, we describe self-developed tools, scanners of social networks, tools for forming dynamic RSS feeds, and the results of their integration into a single system. The collected complete data is converted into the text corpus format required for the study, up to XML format, which can then be loaded into the SWINS information retrieval system. A fragment of XML file is presented on this slide. And in general, the technique described above can be used to extract data, analyze text published by users of the Telegram Messenger. It should be noticed that a similar technique, with some adaptations, was used to form text arrays from other social media. The system for analysis of big data from social media provides the implementation of such functions. First of them is formation of the information font by collecting according to certain criteria and account of the information given in national coding from internet research, social networks, video hosting, scientific communities, messenger, etc. Second is setting up the modules for automatic scanning and primary processing of information from websites and social networks by the system administrator. Also, presented system provides maintaining retrospective full-text database from information collected from the internet, creating routing database and ensuring the formation of internal vocabulary data sets in different languages using an universal coding system, UTF-8. Also, system provides identification of duplicates and similar information messages, including in different languages, grouping of duplicates and similar information messages in the search engine results. Also implement a full text search using queries in different languages. Initial analysis of text messages stores in the system database. Automatic detection of named entities, face, company names, brands, etc. Determination of tonality, identification of support words by statistical algorithm in information materials in different languages. Formation of analytical reports including information portraits and plots, which are based on the use of keywords in different languages, thematic replication documents. Also, presented system has an integration with geographic information system. Presented system also provides data analysis and visualization of statistical data. For example, visualization is made according to certain source or according to the number of downloaded messages for a period of time. The presented system uses of wavelet analysis to study thematic information flows. The technology of using wavelets make it possible to identify single and irregular bursts, sharp changes in the values of quantitative indicators at different time periods, in particular the volume of thematic publication on social media. Also, it should be noted that well-known wavelets such as Mexican hat and Morlet wavelet reflect accurately the dynamic of information operations. One of the advantages of presented system is prediction of the event's development based on the analysis of the publication dynamics in social media. For this purpose, the fractal theory and nonlinear analysis method are used. And at the end, it's worth noting that presented system provides access to many users to this system, delimiting access to system resources. The basis of the hardware platform of system for analyzing big data from social media are the servers such as information proxy server, data collection server, analytics server, and front-end server. Okay, let's move on to the interface of described above system for analyzing big data from social media that called cyber aggregator. The system user is provided with the documents upon request both in the retrospective database using button search and in the current information using button current, as well as for data analysis using button analysis. The main element of the interface is a digest of the most relevant messages. In the separate block named Queries that is located on the left side, saved user queries are reflected. Statistical information regarding filling in the system database from individual social media is available in the special section named Source Statistics on the right side. As a result of search by request, a list of relevant message headers with hyperlink to the full text of these messages are shown. It is possible to output the found messages in RSS format and display the search result with details on the geographical map, which is scaled both in automatic mode and through setting. Analytical mode, the button analysis, provides user with a number of tools, the first of which is a graph, corresponding to the time series of the number of relevant message requests per day. Using the button digest, users have opportunity to view the main plots on the topic, clusters grouped according to the predefined keywords. The system provides modes for forming networks of concepts that correspond to individual messages and information source. These modes allow to rate the concepts and explore the relationships between them. The analytics mode provides the possibility for forecasting by the method suggested by SORNet. Using the SORNet model, you can obtain forecast values for the number of relevant publications based on the monitoring data. In conclusion, the practical significance of the obtained result is to create a working model of the content monitoring and analysis of social media system, ready for use as a component of decision support system for information and cybersecurity. And the main area of further research is the automatic generation of domain model, semantic maps, and scenarios of alternatives in the cybersecurity fields. Okay, thank you all for attention.